Hey, it's Mr. Allred, and we're going to talk about percents. And we're going to look at percents as they are in decimal and fraction form. And we're also going to look at percent proportions and solve a couple word type problems there. But first of all, percent is used to describe what portion of a whole we are talking about. So basically, when we talk about parts of something, depending on how much we start with, we may describe that differently, and a percent gives us a common base for that. So fractions such as like 1/2 and 1/3 don't compare too easily unless you really understand how they're being broken up. But when we write them as a percent, that makes it a little bit easier. But what we're going to say is if we were given a fraction, you can divide the fraction out and then multiply by 100 to get a percent. So the couple of examples I've got here is 5 out of 100, 5 out of 10. So if we're trying to describe 5 out of 10, we could write that as the fraction 5 over 10, which is definitely 0.5 if you divide it. You can put in a calculator, you can call it 1/2 if you like. But as a percent, we'll multiply by 100, which will move that decimal place over to. So that's 50%. Counter to that, 3 out of 5, we could say that's 3/5. And we divide it, it'd be 0.6. And when we rewrite it as a percent, by moving that over and multiplying by 100, it'll be 60%. So we can see that 3 out of 5, or 3/5, is a larger portion than 5 out of 10 or 1/2. And maybe in the original form, it's a little hard to tell which is bigger. But when you write them as percent, they're going to be looking like common numbers to you, so you can compare them easily. Just by itself, here is an example. I got write 0.52 as a percent. So basically what I did up here with the 1/2 or the 0.5 was move the decimal place over 2. Same thing with the 0.6. So I'm going to move the decimal place over 2, and it would be 52%. Okay, so sometimes you might be given a portion in a decimal form and have to work with it. So you might not start with a fraction. It might throw you off if you're not looking at it as a longer problem. Okay, so we can write fractions and decimals as percents. So next I want to talk about percent proportions. So proportions was a way that we could compare two rates and or two ratios if we like. We might write a little bit different. But what we're going to do is we're going to use the proportion to set up percent problems so we can calculate any of the three things here. The percent, the part, or the whole, as long as we have everything else. You see the proportion that says part over whole equals the percent over 100. That 100 is never going to change. And off to the side, here I've got what looks like a fraction that says is over of. So when reading a problem, if it's not explicit, it may be hard to figure out what part of the problem is the part or the whole. Especially if you're given one number, you might have trouble determining, am I looking for the piece of it or am I looking for the whole? So these is over of will be kind of a helpful way to bring that information about, and I'll show you how to do that. Okay, but we're going to set up proportions, cross multiply them like proportions, and solve for what's missing. So let's see here. What is 35% of 400? So in this case right here, the percent is the percent. It's always just going to have that association with it, so there's no real way to kind of get that mixed up, I hope. But we see the two words here. We see is and of. And if we look at them, while the percent's there in the middle, the is associated with the what here, and the of is associated with the 400. Okay? What is 35%? So what is the piece of 400? So of means we're taking it out of that whole. Okay, so there's the is over of that helps us set up the part over the whole. So that proportion will look like, we don't know the part, but we do know the whole, so x over 400 will be 35% over 100. and then we're going to cross multiply this and solve it. So after cross multiplying, we'll have 100x equals, I've got a calculator here, 400 times 35, 14,000. So if I divide by the 100, which is pretty easy, we're just moving something over, looks like I get 140. So basically what that tells us is 140 is 35% of 400. Okay, so make sure you understand how I set up that proportion. The part over the whole, and I use the words there as keys to kind of determine what the part is and what the whole is. Let's see here. 312 is 65% of what number? Now the wording here is not much different, but it is asking us for a different thing. So once again, the 65% is kind of by itself. That's not a part or a whole. It's a part, but the percent kind of gives it away. But 312 is, that's the part of what? We don't know the whole. So let's put that together. That would be 312 over x, since we don't know the whole, equal to 65% over 100. Cross multiply. And let's see what we get. We get 65x equals 312 times 100 is 31,200. Divide both of these by 65. It's possible I should have asked you to round something here. Let's see what happens. 31,200 divided by 65. I'm getting 480. So we can go back to that sentence and replace the what and kind of make sense of it. 312 is 65% of 480. Okay. Let's see, I got at least one more example here. 30 is what percent of 600? So here's the is and here's the of. Now be careful because you see the is and the what there, but it says what percent. So the percent is a thing we don't know. So the is between the 30 and the percent part. So 30 is, that's the part, of 600, that's the whole. So we have 30 over 600, that's the part over the whole, equals what percent? We don't know. That's the x over 100. Cross multiply. Just how we saw proportions in the first section we did. 600x equals, looks like 3,000. I put too many zeros. I have an eraser. Yes, 3,000. So I'll divide by the 600. Get a little messy there. But it looks like I get 50, I think. So let me just double check that. 3,000. Divided by 600, more like 5. 5, yeah. Good thing I checked. So 30 is 5%. So let me just kind of put that percent with it. So 30 is 5% of 600. Okay. Going good, I think. Let's see here. We've got some word problems. Tim must call 74 students about registration. If he has called 25 students so far, what percent has he called? You may have various approaches to this, but kind of think about it in the context here of part and whole. You're looking for the percent. So he has 74 to call, that's the whole, and the part is the 25. We don't know the percent. It's out of 100. We'll cross multiply. We get 74x equals 2,500. Divide both sides by 74. What percent has he called? Let's see here. 2,500 divided by 74. I say round to the nearest tenth of a percent. I get 33.8%. Okay. The next one here. Angel is on page 329 of the novel with 483 total pages. What percent of the book does she have left to read? So let's be careful with this. So it says right here she is, so sometimes they work out good, and there's a of, so that's kind of scary the way you see them laid out. But Angel is on page 329 of the total. So if you capture both of those, it kind of works out really nice. But writing this out, we've got 329 over 483. That will give us a percent. We'll cross multiply. So I got 483x equals 32,900 divided by the 483. Let's see, 32,900 divided by 483. I get that x equals 68.1%. But let's go back to the question. What percent of the book does she have left to read? So she read 329 of the 483, so this is what she has read. Remember that the percent is out of 100. So if you take that percent out of the 100, 100 minus 68.1, we have 31.9% left to read. Sorry about the mess there. So we found out how much she has read. We found out also how much she needs or she has left to read. Alright, I got two problems here. I have a time limit on how much time I can use, so let's see here. 83 students show up for open house at a local middle school. It is reported that this was only 37% of the total students. Calculate the total number of students at the school. Alright, so 83 is how many showed up. That's the part of the total. And that's 37 out of 100 as far as the percent goes. Let's see, 8,300 equals 37x, divide both sides by 37. Let's see, 8,300 divided by 37. It says calculate the total number of students at the school and round to the nearest whole number. I'm getting that this is about 224 students. Okay. So we were told how many showed up, and we're looking for that's out of how many. So the part is the 83, the whole is the thing we don't have. Oh no, there's two more problems. I guess we'll pause and pick it back up.